Welcome. Thank you very much for your time. Thank you for registering and attending our webinar. My name is Ralph George. I'm the creator of SmileFy, and today I'm going to present to you the overview. SmileFy is a platform that works on iPhone, iPad, and iMac, MacBook Air, MacBook Pro devices. You can use all devices for every single feature. So even if you want to create a veneer on the iPhone, you can. One of the most important philosophies of SmileFi is communication can be useless, comprehension cannot. The digital patient is where comprehension begins. So what we do with SmileFi, we create a digital version of the patient using picture, intraoral scans, CBCT, facial scans, whatever you have. And then we create the calibration, we create a digital patient, and we start using the digital patient for all our projects. Now, we do have around 320 people registered. Anyone who cannot be live, we will send the recording afterwards. And we do have different attendees, right? Some of you know about Smile Design, about SmileFi. Some of you are completely new. So I'm going to make an overview, and I'm going to show you then much more in-depth clinical cases and what we can do with SmileFi. So SmileFi has 3 steps. First, we create a digital patient. We take digital records of the patient and we create a digital patient. Then we have the smile simulation, the 2D smile simulation, which is purely motivational. 2D design can be always motivational. So 2D design has never a clinical value. And then we create, after the smile simulation, we create a 3D smile simulation that's for edentulous patients. And then we have the 3D smile design, which is the feature that allows you to create mock-ups, motivational mock-ups, ideal designs, clinical cases, treatment plans, and so on. So let me show you step by step how we use everything what I described here. So for the beginners, it is very important when we have a patient coming into the office, we need a tool to motivate the patient for an aesthetic treatment. How can we motivate the patient for an aesthetic treatment in 1 minute using the 2D smile simulation technology powered by AI? We have a picture. As you can see, there is automatically a facial analysis of the picture. The smile frame is calculated automatically based on the position of the teeth, lips, facial proportions, facial harmony. We do have a lot of scientific papers integrated in SmileFi. In this case, that's the facial flow, so that we analyze the facial harmony of the patient and know the interpupillar line, the commissural line, and the chin, the midline, glabella, tip of the nose, philtrum, how the face is divided, and in which direction the face goes, in which direction the chin goes, so that we can calculate and design a smile that is very, very, in harmony with the face. You can, of course, change the height of the smile frame of your smile. You can change the ratio of the smile. If the calculation is good enough and you like it, you just click on the button Smile Simulation, and we calculate 4 different designs. The difference for these designs are, we do have one version, open embrasures. We do have closed embrasures. We have triangular shapes, and we have mixed shapes. If the patient says, I like round shapes, then you can select one version that you like. And from here, we can go and adjust, if needed, the smile. And in this step, we need to get two important information from the patient. So we have two questions for the patient. Do you like the shapes? Round, triangular, oval? What do you like? I like the shapes. Okay. One of the most important and very powerful features in the smile harmony is called smile dominance. You can have a monotonic smile where you can see that the laterals are on the new smile curve. They lie on the new smile curve, right? We redefined with our smile frame the smile curve, following a little bit the lower lip, the roundness of the lower lip. The laterals now touch the new smile curve, or we add some dominance to the smile like this, and that changes the complete smile, right? She is more edgy, she is more it's a sign of youth. The dominance of the smile can change the harmony, can change a lot of the appearance of the patient. If the patient says, I like the dominance, maybe too much, but we can reduce the dominance like 50%, that's good. I like it. Now we have the most important information. Patient likes oval shapes. Patient likes 50% dominance. That's it. That's the 2D smile design. We do have options to click on a tooth, move the tooth around, change the size, change the width, the height, whatever it is. It doesn't matter, because this kind of smile is motivational and has no clinical value. The patient is motivated. I spend 1, 2, 3 minutes in a discussion with the patient to show the advantage of an aesthetic treatment. Now the patient is motivated. I can share with my patient the picture before and after. By just clicking on the slider. And then I can also show my patient the before and after picture, and that's it. Patient is motivated. Patient wants to know more about the aesthetic treatment. That's good enough for us. We start the discussion with the treatment. We can do the scan, the intraoral scan. We can do the CBCT. We can do the facial scan, whatever files do you have. And then we add all these files, the digital records, to the patient documentation, and we create the digital patient. So the 2D smile simulation is done. The 2D smile simulation can be learned in 10 minutes. So it's because the app calculates everything automatically, everything based on facial proportions, facial thirds, smile curves, and all this stuff. You can learn easily the 2D smile simulation in 10 minutes. You try different cases, and then you can go and immediately start motivating your patient with the 2D smile simulation. If you have patients, edentulous patients, we do have a different simulation, a 3D simulation, which is now based on a 3D model of a full arch implant bridge. We do have an edentulous patient, and as you can see, we have, let me see what happened with the light. Let me redo the case again. And okay. Edentulous patients. The idea is not only to, because edentulous patients, they are motivated anyway. So it's not the idea to motivate the patient to an aesthetic treatment. The idea is to find out what templates, what form of the templates the patient likes, to find out where to put the teeth in the face. That's the most important thing, because the patient has no reference. We don't know anything about where the teeth were, where everything was, right? So what we need now is to set the templates, the smile in the face, to find out what form the patient likes by just selecting, you see, different forms of the teeth like this. And then the patient says, oh, I liked J01, for example, that was close to my teeth. And then we can show the patient also the full arch implant bridge like this. Comparing different forms of smiles, we put that smile in the face of the patient. It's a facially driven design. And then when we start creating the real case with implants or dentures or removable dentures or full arch implant bridges, we know where the teeth should be in the face, and based on this simulation, we will adjust the size of the full arch implant bridge on the patient's arch, and we will plan the treatment accordingly to what we have. Now, it's a little bit different than the 2D smile design, because one of the big limitations of 2D smile design is the position of the patient in the picture. When the patient is frontal in the picture, then the smile, the 2D smile design is always frontal. But if the patient looks up, down, to the right, or to the left, then we have a problem, because the patient looks to the side and the 2D smile is straight to the screen. In this case, it doesn't matter, because we can now follow, let me show you like this. We can follow the orientation of the teeth with the face. So we can rotate, we can follow the face, and then create actually a very, very specific and accurate simulation of the smile. More than that, we have the buccal corridor that we can change. You see, the buccal corridor. We do have the lower jaw to the lower jaw to the picture, and the rotation. It is important because we don't know, our models are in centric occlusion, but we don't know how big the patient is going to smile. If the patient smiles big, then we have a different jaw position, so the lower jaw needs to follow the lower jaw, and it's easy. We do have the position, we have the rotation, and we can simulate a very, very precise position of the new smile. If the lip points, if the lip are not marked accurately by the AI, you have here, you see the option to move the sliders and adjust the points of the lip, and then you have the accurate simulation of the smile. So that's the 3D smile simulation. And you do have also the Vita colors here that you can use, the Vita colors, and add intensity A1, B2, B3, M3, and so on. And we do have here also different structures of the teeth with more translucency, color 2, brightness. So you can play with all these, with the light. You see, we have the light reflections. So we can create good simulation of the smile, and then show the patient the form of the teeth and so on. That's the smile simulation. Now, let's go to the 3D smile design, because the 3D smile design is powerful, and it's it is the start of the treatment plan. we start with the mockup, with the motivational mockup. Starting with the motivational mockup, I need to show you something. It is a new feature that I worked for the last couple of months, maybe, yeah. I need to just to start a different prototype here. It is the AI mockup. 2016, when I first created the first Smile simulation, I could reduce the design time for 1 hour, 40 minutes, 1 hour to 15 minutes. Then with the AI Smile simulation, we reduced the time from 15 minutes to 1 minute. But the 3D Smile design is still, it requires a lot of time, it requires a lot of knowledge, it requires more expertise. So the idea was, how can I optimize? How can I automate the full 3D Smile design in a way that we can get a 3D Smile design in minutes? And of course, the AI technology is now very, very important topic. It is an extreme complicated technology, and it's extreme using the clouds and Amazon Web Services. You need special servers that can calculate a lot of data. But finally, I could create a workflow for the mockup, for the motivational mockup, that takes minutes to create a 3D Smile design. Now, just imagine if you send your Smile design to your lab. It takes maybe 1 week, maybe 2 weeks. Then back and forth. I don't like the canines, change the size, angulation, and all this stuff. I want you to have control over the case and the mockup. Change the mockup in minutes when you have to, and then print the mockup in the first appointment. How that works is interesting and exciting, and I'm very happy that I can present you a new way to design 3 cases. First of all, we do have the picture and the intraoral scan. If you do have an intraoral scan with colors and OBJ, then you can use the OBJ with colors, and then you have a beautiful visualization of the upper jaw. We do have the first step, and the first step is manually done. 3 points on the intraoral scan, 3 points on the picture. So I don't have the time and the resources, to optimize, to automate also this step right now. So we're gonna work on it, but to a later point, so that we can finalize actually what is way more important. It's the 3D Smile design. This step can be done manually. That's totally fine. And now what happens here, it's very, very fast and very, very fascinating, I think. In the first step, we calculate automatically the occlusal plane from the intraoral scan. As you can see, the occlusal plane, the profile, and the occlusal view are set automatically and accurate. If you have the palatal area, then we see the midline of the scan, and you can see the midline is pretty accurate. We could calculate the design automatically for you, but nevertheless, I want you to make some decisions, because it is important to know, do we have a symmetric arch or we don't? Is the patient open for an ortho treatment or not? Because if you think I can present to my patient an ideal smile design with a symmetric occlusal curve, then you select here ideal, type of the occlusal curve, ideal. And then when we calculate the curve automatically, you see it is symmetric. And here it's following the patient arch. Here we need actually more space to expand actually the arch to make it symmetric, or to correct with the thickness of the veneers. But the occlusal curve is calculated automatically. And now we go to the next step, two clicks, and we calculate the 3D smile design. Boom, done. We do have now the 3D smile design. We can discuss with the patient now the templates, the form of the templates. What do you like? Do you like the round, triangle, square? Do you like the open embrasures, closed embrasure, incisal edges, buccal surfaces? So we can discuss all these details with the patient. When the patient says, actually, I like the smile, that's fine, good. Then we need to finalize the smile. And as you can see, the gingival margins of the centrals are not covered by the design, by the motivational mock-up. But the motivational mock-up is additive, so we need to cover the patient's teeth. And we can use the mesh editor. This step will be also automated, so we will analyze what is the patient design, the patient's teeth, and then we will cover here automatically the gingival margins. And like this. And now the only thing that is left for the mock-up is to delete from the palatal area the material excess, right? So that the mock-up is gonna be additive like veneers, and the patient has a beautiful experience and can close the mouth without having material in the mouth. Here we go. There is something that I don't like here in this case, but for that we go now, because we have the 3D smile design done, as you can see, and it was 2 clicks and 1 minute adjustment. Now we have the time to discuss with the patient something that is very, very cool, and I integrated in SmileFy decades of knowledge and scientific papers regarding smile harmony. What do I mean? Number one, we do have the facial proportions and the facial flow. So we analyze the facial flow of the patient. It is a beautiful study written by Christine Coachman, Bruno Pereira, Kyle Stanley, and Eduardo Mann. Intrapupillar line, commissure line, are they parallel or not? Number two, the midline of the face is not a midline. It's a curve created by the glabella, tip of the nose, philtrum, and chin. 95% of the patients, they have a facial flow. Understanding the facial flow is important, because if the chin of the patient goes to a certain, to the right or to the left, and your design is following the opposite direction, because of the crossing lines in the face, chin goes in one direction, smile goes into the opposite direction, you create a visual tension in the face. Creating a visual tension in the face, the smile that we create is not in harmony with the face. So we analyze the face, we know what we can do, and we know what we shouldn't do. That's the first facial flow analysis. Then we do have, and that's fascinating, the zenith analysis. We have the highest point of the gingiva, and we analyze now the triangles created by these 3 points. And we see that we have different angulations. We have different values for the angulations, different distances between the original zenith of the lateral and canine. And now we can discuss with the patient to bring your smile in the perfect harmony. We need to make sure that these two triangles are as close as possible and as symmetric as possible. It means we could correct with the gingivectomy the gingival margins of your left central, lateral, and canine, and create the same size on the right side and left side, because as you can see on the right side, you do have a higher gingival margin than on the left side. So you can talk now about gingivectomies, you can talk about the treatment plan, you can talk about very, very specific details, how after the smile analysis, how can you create the smile in a very, very harmonic and natural way. And also we see that the gingival margins for the centrals are not the same. And that's something that disturbs me, because what you see in a smile is always the centrals, and the centrals needs to be the same size, gingival margins, round, symmetric, beautiful, because that's gonna be the first thing that you see in a smile. And we have here a complete different gingival margins form than on this other side. So we need to correct that. Patient has a beautiful visualization of what can be done, and then we can discuss the treatment. Another very important aspect of the smile design is the axial angulation of the teeth. As you can see, let me turn off the lights here, the rendering. So as you can see, we do have on one side, the canine has a different axial angulation than this one. You click, you reflect the angulation on from the opposite canine, and now we do have both canines in the same angulation, and that creates a better harmony of the smile when we do have these axial angulations the same on the right and left side. Smile analysis, of course, we can do some measurements. We can click and say, look, we're gonna increase your central with 1.5 millimeters, and a lot of stuff that we can do. Also, what we can do is to visualize digitally the gingivectomy and the gingival corrections. For we can go to the mesh editor, and with the brushes that we have, you see now we can deform and simulate actually a gingival correction like this, and here it's gonna be a little bit complicated, but we can smooth out, we can do it like this. We need actually to make sure that both sides are gonna be more or less the same, in the same form. Not quite, but that's the idea. Smooth out. So, and then suddenly I can show to my patient, look, that's the gingival correction. Now we have on both sides, we have the same size of your veneers, and that's gonna be a smile that is much more in harmony with your face and everything. Now, one very important advantage of SmileFy is that every time you do something and you modify the layers, we create new layers. So you don't need to duplicate, layers or things. You don't need to duplicate layers, because that's the original intraoral scan, and because I changed the scan and I simulated the gingivectomy, I have now, let me make it like this. I have now the option to compare. You see? I have the option to compare. So we duplicate everything what is changed. You just focus on the smile design and you focus on the on everything what needs to be done. The central is not, I'm not happy with the central, but I'm not gonna do more now with the mesh editor because I need to show you more stuff, but that's the idea. If we take the time, then we can really copy the gingival margins and we create a beautiful digital plan with gingivectomy and a beautiful result. Now the patient is motivated. We'll go to the CAT features and you just click on the mockup button and we prepare the file for printing. Very important to realize right now, we didn't spend our time, and that's very, very important. We didn't spend our time trying to place our teeth and templates in the right position. That was given by the technology. What we worked was patient communication, explaining what needs to be done, what can be done. Smile analysis, we analyzed the axial angulation of the teeth, the gingival margins, the triangles. So we had actually a better and deeper discussion into the smile characteristics and smile harmony than trying to fight with the technology. Right? Good. That's the automatic mockup. And now for the ones who are a little bit more advanced, I want to show you something that is also very, very unique in 3D Smile design. It's very unique. It's very powerful. It's also automated. And now we do have the design and we do have the mockup. We want to finalize the design and to print veneers, to finalize the treatment plan digitally and all the stuff. So now I'm going to show you for the more advanced users some very, very unique features, also automated, also powered by AI. How can we now analyze the accuracy of our smile and how to create, for example, printed veneers and, temporaries and all this other stuff. If you have questions, please ask in the chat. Daniel is one of our specialists. He's going to answer the questions. I'm going to answer the questions. We do have, our team is with you. So it's going to be an interaction. Oh, as you can see, there is some weather outside. Okay, let's start here. The newest update, which is going to be released in August. Now, after the motivational mockup, everything what I'm going to show you now, it's a little bit more advanced. It's a little bit more advanced from a design perspective, but it is very easy to use because that's the idea. I want you to have an iPad and to be able to correct the interproximal spaces. I want you to have an iPhone, open the case on an iPhone and do some 3D Smile designs on the iPhone and send to the printer. Okay, so that's the idea, to have a system that is really advanced and unique and automated and not only makes it makes fun to use it, but you can bring a lot of added value to the patient communication. Okay, so here we go. Let me show you. We have 3 important features gonna be released in the next 2 weeks, so until the 1st of September. Also a very, very interesting and unique technology. And I think you will understand when I show you how easy it is to use it, then it's gonna make more sense for us to discuss all this stuff. When I do have the design done in the first step, right, everything is fine, but I don't have any details about the interproximal contacts, right? I do have my templates. They are now in the right place. It's beautiful, but the question is, do I have clean interproximal spaces? So let me show you something very, very unique. We worked a couple of months on these new features, very, very intense, very new technology, very unique technology. And finally, it works exactly the same way I envision it. So let me delete here in the palatal area everything what is not, should not be here for our purposes, for the veneers. Like this, that's fine. Good. So Liquify. Liquify is a technology that I developed to be able to adjust the design and the gingival margins, preserving the morphology of the templates. What happens is when you use brushes and you try to deform a template, a solid template, you destroy actually the morphology of the buccal surface. So my goal was a technology that we can use to preserve every single beautiful detail of the natural topology of the templates, right? The first feature that we have is called deformation. So you click on a tooth, the tooth jumps in the middle of the screen like this. And now you can adjust the gingival margins in a very unique way. You click on the point and you move the point. The template is now liquid, and having the template liquid, we can move areas around like this, as you can see, and we can adjust the gingival margins very, very easily and very, very precisely. Also here, for example, I can have this. I can flatten the buccal surface. I can make it more round. What do we have? As you can see, also the rendering, the 3D rendering that we have is also very, very unique. I wanted to have a very good quality of the teeth, of the rendering, of the smile, of the lights. Here also I click, and you see I can very, very precisely adjust the gingival margins. Good. That's one feature. Now, what about the interproximal spaces? Maybe they're not clean enough. I analyze now the interproximal spaces, and the AI creates me a visualization of the conflicts in my design. We see the design, we see the buccal surface, we don't see what is inside between the teeth in the palatal area. Here is our result. Here is clean. Here we have the conflicts, right? Now I ask you kindly not to breathe and not to blink, because you will miss the correction. It's that fast, okay? So don't blink, don't breathe. Correction, boom, done. Now, as you can see, the interproximal contacts are corrected and our smile is done. So we do have the deformation in a very, very specific and accurate way. And then we have the interproximal spaces. We can use the same technology for contacts up or lower, occlusion up or lower, occlusion upper design, original intraoral scan lower. So we can readjust and readjust actually the contact points and the position based on the patient situation, so that you have the crowns and everything is adjusted properly. And then we go to the advanced feature, where we do have the option now to create veneers, to 3D print veneers. So we mark margins, we set safety area for the material that we're going to use. So if we want to mill, we will create a safety area of 0.45 millimeters. If we want to print, it doesn't matter, because we can print way more thinner than milling. And what we do, we mark the margins like this. Like this. We can readjust the points. We can do, you know, everything what we need to do. That's nothing new. That's not unique. I didn't invent this. The liquify I invented, but this one, no. You know, that's veneers and marking margins is nothing new, but now it's new for SmileFy. Here we go. We have the tooth. We can see the margins, and very important, we can change the position of the light so that we find the margins better and see actually the margins better. You see the margins are I didn't mark the margins properly, because I should follow this line here, but we can recorrect the margins, and then we can create the veneer. We can print, we can add a cement gap of 50 microns or 100 microns, the cement gap, and we create an STL, we export, and we can print. Now, also for a little bit more advanced users, what I realized, when we segment the teeth automatically at the beginning, we can offer you the option, and that's something new, and I just realized it's very, very interesting. We can offer you the option to combine templates with the patient's teeth segmented. Why? Because sometimes, like this girl, you do have an inverted smile, but the form of the teeth is very unique for her face, for her facial energy and harmony. The canine is beautiful, actually. The central is very unique, the lateral also. So why not segment patient's teeth, and it's like a self-donator of the smile, but with corrected sizes and rotations. And now look how she looks like with corrected sizes, but using her own form of the teeth, right? Using her own teeth for the smile design. So as you can see, we do have very, very interesting features. Also, we can measure from the design what you change in the design. We can make sure that the design is properly done by analyzing the incisal angulation, so that we make sure that the angulations get bigger from central to the canine. So if this value is smaller than this value, then the smile wouldn't be in harmony with the face and with the nature. Then we have the axial angulations, the zenith. We have facial scan integration. We have the medical viewer cross section, so we can measure the bone margin. We can we can create really complicated cases like this one, where she was just, oh, I want new incisal edges, and and when we designed, we could visualize that's the correction of the incisal edges. But if we consider the CBCT file, we measure the bone margin, we measure the soft tissue, and we create the biological width with the crown lengthening, that's the result that we can offer her, right? And then the patient has a visualization of the digital treatment plan and understands, why do I need to go through a surgery, crown lengthening, gingivectomy, because now I understand how my smile can look like, instead of, you know, just a simulation, which is not the reality of a treatment plan. That's the overview of SmileFy.